and award-winning speaker tonight named Brian Tarbox. He's going to give us an overview of Amazon Web Services with selected deep dives. Please take it away, Brian.
Thank you, Morgan. Always love your introductions. If I could get you to come along with me whenever I have an interview, that would just be that would be wonderful. So,
Brian, if you're on the market, we'll hire you. So don't worry about that.
Okay. So what I'm going to do is mostly do a screen share, so let me do that now. Okay. And so if you have any questions at any time, please jump in. I will say this talk, I'm also going to be giving this talk at New England Java Users Group later this week, and the organizer of that group asked me if they could look at my slides ahead of time, and I said, but I don't want to do slides. I want to do live stuff. But they said I should have slides, so here are a small number of requisite slides. But don't worry, we're going to jump right over them. So this is the main Amazon Web Services page listing the 60 or so services they provide. That's as much as I want to do slides. And the really cool thing is that this isn't even all of the services they offer, but it's a bunch of them. So sort of this is the last slide, and I suppose I shouldn't let you see the notes, but what I really want to do is show you the different ways that you can look at the cloud. Amazon gives you a whole bunch of different approaches you can take, and then leaves it up to you. And they don't really seem to have a bias for one approach or the other, but it's interesting to see the range of choices you have. So we're gonna start with just spinning up some raw machines, and for a lot of people that's just what the cloud is. Give me a raw machine up there and leave me alone, and I'll do what I want to do. You can also have managed services. So let's suppose you want to have a database, but you don't really want to manage the database. Well, Amazon can do that for you. And someone's breathing on the phone, but that's okay. Okay. You can also create entire sets of infrastructure, lots of different resources, and put that together. Or perhaps the most interesting thing is this last one: no servers at all. This is one of my continuing plugs for Lambdas, where I've said to Morgan, in 5 years we may look back and say, "Hey, remember when we needed computers?" So we'll get into all of that. So with that said, let's ditch the slides and let's go to the live console. And so the first thing you see when you get here is the list of all the services, in this column, Amazon will break down the services for you into categories, and theoretically that's helpful, but I actually just like to go to all the services and jump over here. You can also have a history of the services you want. You can also pin services up here. So I like to use EC2 and VPC and Direct Connect, but if I wanted to pin any other services up there, I can just grab them and stick them right up here, and away we go. And that's really handy because there really are so many. Okay. So when you click on EC2, it takes a while to get used to the console, but it will typically tell you all the things that you're using. And remember, when you start using things, you're paying for them. Not a lot, but you're paying for them. And you can if you let things get out of control, you can end up paying a lot more than you want. And
So
so I
just just to ask a novice question, the page you are showing us is something that I would need some kind of Amazon credential to see, right?
yes, okay, right. So
Great. Okay.
if you if you don't have an account, they'll be happy to make an account for you.
Okay.
Um,
And since I've already rudely interrupted you, let me just continue my interruption and say welcome to those who've joined us. Glad to have you in our little virtual hangout. And I'm a little I'm not very shy, so I'm going to feel bold and interrupt when I have a question. And I hope people feel this is their group and can do so also.
right, please do so. So I've set up my account. Uh, a lot of the services are free or charge literally, pennies on the hour of service. Um, uh, but I've been at companies that accidentally got, all of a sudden a $10,000 bill, and while that's maybe not terrible for a company, for an individual that would be catastrophic. So we're going to pay attention, and I make sure I'm not running too many things. But you can see that we have over here, we have instances, and that's what we call virtual machines, or just computers in the cloud. We have different types of instances, and we can go into details here. We'll talk about what AMIs are. There's a whole alphabet soup, of course, for Amazon. Um, uh, every time, one of the interesting things with Amazon is that they roll things out at a pace that is simply astonishing. So, for instance, bundle task. I've never seen that before. I've been doing this for 3 years. I come to this page every day. I've never seen this before. I think they rolled this out today. So um, they're innovating at a kind of crazy pace. You have volumes and all kinds of network security stuff, and we'll get into that in some detail. But for now, we have a couple instances. So you see this guy, Brian Nijug 1, and you see that it's terminated because I messed it up. So I couldn't actually log into it. So I messed it up, and I created instead Brian Nijug 2. And let's walk through how you create an instance, and then we'll actually jump on one. So let's suppose you just want to play around with a computer that doesn't happen to sit on your desk. So you say launch an instance, and there's a whole, there's 6 questions or 6 pages of questions you have to answer, but almost all of them you can default, and it's probably the best thing to default. But let's suppose we want to do, a Linux computer, and you could do SUSE or Ubuntu. I haven't run Windows, but I'm sure you can do that. And so I say I want a 64-bit computer. This next step is, well, what kind of computer do I want? So you see here, we have the family of computers. So these guys are all what they consider general purpose computers. These guys that start with the letter C are compute optimized. So if your task requires a lot of processor, you might want a compute-oriented computer. If it had even more processing requirements, you might want a GPU-based computer. If you required a lot of memory, you might want one of these memory optimized. And if you had tons of disks or were running a database, you might want a storage optimized. Now, the interesting thing here is we see basically how to describe the machines. And here we have virtual CPUs. And in this era of changing processors and cores, basically they needed to pick a standard. So they have what they call a virtual CPU, and then over here an amount of memory. So you can get this is a brand new one, a T2 Nano with 1 core and half a gig of memory. And it's hard to imagine. I mean, I think my Apple Watch has more processors than that, but there's uses for that. And why pay for something that's more than you need? You can flip down here to one of these guys, and it has 40 cores and 160 gig of memory. And then over here you have the types of disks that are associated with the machine. And if it seems like I'm tossing a lot at you right now, we basically have to sort of get started and level set before we can sort of dive into the perhaps more interesting things. But when you're running one of these virtual computers, at a certain level, Amazon tries to keep you from having to worry about the fact that it's virtual, and you can just treat it like, just the regular computer that's on your desk. But bear in mind that it actually is a virtual computer, and you're basically having a hypervisor is running someplace and carving you out resources of a bigger machine. Now, one of the places where that gets interesting is you say, well, what about the disks? Well, obviously, if you had disks on that machine, that would be faster, okay? And that's where you would get into what we call instant store. So these guys, these low-end machines, don't have instant store. They only have external store. These guys have different amounts of instant store. So that's much faster. So that's another one of the decisions that you might use in picking which one of these types of machines. Over here you have the network performance as well. One of the things that's really quite interesting is if we go to the bottom, you can get a machine here with in i2x, 28x large, 32 cores, and a quarter terabyte of physical memory. And 800 gig solid state drives. So that's quite a beast. But they recently announced an even larger machine, pricing yet to be determined, but a machine, I think it's now called the X class, the X1, that has 100 cores and a terabyte of physical memory. I mean, that is truly a beast of a machine. But that costs a little bit. One of the things I'll show you if I pick the right tab is this is basically their pricing chart. And so we have the same list of the machines over here, and their cores and storage and so on, and you can see pricing. So these nano machines that we're going to be playing with for a bit, 0.6 of a penny an hour, or 0.4 of a penny an hour, and we'll get into the difference between on-demand and reserved. But you can run these things for quite a while and incur almost no charge whatsoever. I mean, you have to run for quite a while before you have to pay $1. Okay, so moving on.
The only thing that worries me about that long chart is that I don't think I'd have any way to predict ahead of time which row to pick. I mean, how would I know? I guess I don't have any sense of taste of knowing which kind of a machine do I need. Is that something I only can find out after I deploy my app, or is there some sense of taste people acquire?
It is part of sort of the art of the thing, in that they have, they really have a wide range of machines, and there are a wide range of reserving them and paying for them, and so you really do need to know a fair bit about your app. One of the things, it sort of depends at a certain level. Are you running one? If you're running one Java app on your machine, and you don't want to have more than say an 8 gig heap, well then that sort of points you at one of one of these classes machines. Why have if you've got one Java app that's running with 8 gig of memory, in your JVM, why would you possibly need 32? But if you're going to be running 3 such apps, maybe you do want them. So it really is sort of a trial and error and a black art to it. And just as if that wasn't hard enough, these T instances are what we call burstable. And basically, a lot of applications have the usage pattern where you start them up, they sit idle for quite a while, then a request comes in, they furiously do a bit of processing, and then they go idle again. And a lot of people used to pick a bigger machine than they needed to handle the burst in activity. And then Amazon came up with this burstable type. So these T instances, let's look at this T2 small. It has 1 virtual CPU and 2 gigabytes of memory, but it also accumulates credits. So if this guy was sitting there idle for a while, he'd build up credits, and then when he got some work to do, he would act for a while like he had 2, 3, or 4 virtual CPUs until you consumed the credits, and then he went back down to his 1. But think of it from Amazon's point of view. Since this is a whole virtualized cluster of machines, if this machine really isn't doing anything, they can sell that capacity to someone else, even if later on the fly someone else needs it. So I think I just told you, yes, that hard problem that you thought was hard is actually harder. So
it almost reminds me of a memory manager where I have so much physical RAM and so much physical disk, and I can run an application that has a larger virtual memory than I have physical RAM because I can page fault. And I'm seeing this burster in an analogous way, thinking, wow, this is like a CPU fault.
yes,
Right?
exactly.
Wow.
It's wonderful.
It's time
wonderful.
travel.
Because the T2s are cheap. What we found in our own company is that using the T-style interfaces saves us 23% of the cost over the other ones. So that's real dollars. But anyway, jumping along just a little bit. So we now can configure all kinds of more parameters. So we're saying we want 1 instance. Well, heck, I want 99 instances. Or I want 1,000 instances. They're happy to give them to you. I'm going to put it back to 1. Spot instances are another whole beast, a wonderful, wonderful beast. We'll get to that if we have time, because that's one of my favorite things. But there's there's all kinds of configuration you can do with networking and subnetting. A VPC is a virtual private cloud, so you can make your machine even more protected from the rest of the internet. IAM roles are a very cool thing Amazon has to allow you to have credentialed access to machines without actually having to put the credentials on the machine. So even if a bad guy gets on the machine, they can't get the credentials, but you still need the credentials to get on the machine. Very, very powerful. There are many day-long courses on that. One of the things that's really quite nifty, protection against accidental termination. Once you've started these machines, they're just in a grid, and you can go ahead and delete them. And if you have server machines that you don't want to delete, it's a really good idea to say this: please don't let me accidentally delete them. It's not as if I have experience, as everyone in Amazon eventually gets, of deleting my Cassandra cluster servers. Check this box; it will save your butt a bunch. There's monitoring. There's all kinds of things we can do. But for now, we're just gonna say no. The defaults are great. This machine starts with an 8 gig root. I could do all kinds of things. I could make this, giant. I could say, no, I want a magnetic disk. Amazon really doesn't want you to use magnetic disks anymore. They'd rather have the SSDs. We can put tags. We'll here say, I will spell my name correctly, eventually. Oh, MetroWestCoders 1. Again, we have all kinds of options for security groups. For the time being, ignore all that. And now we can review. It all looks good because we all pick the default, and we launch it. Now, one last thing is, by default, the way you access your machines is through SSH, and you have to have a key file, and so you need to specify what key file you're going to use. So I'm going to use my key file. And so we launch it. And we can look at the log, and you can see that it did everything correctly. Let's go look at our instances, and we can see that we have one that's dead, one that's running, and one that's pending. Let's just for the sake of time go to one that I set up just before the meeting, which is down here. And you should hopefully see a terminal window. Someone let me know if you don't. But here's our terminal window, and from my Mac, I SSH'd, referring to my key pair, to that machine that's at 202.18. And now I'm sitting on a Linux box, and I can do any old thing I want. Just me. I'm EC2 user. I can update my I can do any old thing I want. It's just a Linux machine. It's all mine. I can do with it what I will, which is pretty cool. So if you have experiments that you want to run with some tool that you want to use, but you don't want to muck up your own development machine. Maybe you want to try a different editor, but you don't want to mess up any of your configuration. Spin up one of these machines, play with it for a while, and go to town. And then
maybe I want that to be my development machine.
Well, that's pretty cool too. There's actually a really interesting style that you can take, in that it is possible for machines to go away, but if you that's actually going to get into a bit of a segue, but let me say this about it. So we spun up a base Linux image, and it doesn't have necessarily all the cool things we wanted. Now we just did a yum update, but I mean we could install IntelliJ, Eclipse, Java, Scala, Go, Salt, all manner of things. Get the machine all the way we wanted it, and then wouldn't it be cool if we didn't have to do that all again? Okay. So what you can do is, let's suppose we've done more yum steps and we had configured this machine to be exactly the way we wanted it. We can then say, we come up on this machine and we say, image, create an image. And what that will do is, remember at the very beginning when we launched the system and we said, I'm going to create a Windows machine, an Ubuntu, whatever. You can also create your own machine. So let's create one. So it's MetroWestCoder, and just for simplicity, I always make these be the same thing. And you're saying I want to create a snapshot of this machine down here exactly as I want it, so that I can launch more of them later on. And this machine closes it because it has to reboot, to take a clean snapshot. And now we're creating an image. I went ahead and did this earlier. We can go to let's see. we can go to, why is that not showing? Well, let's see. Well, and my mouse has frozen. Excellent. Hold on a second. I get enthusiastic and my mouse battery dies. Okay, oh my gosh, look at the time. Okay, I'm gonna rush forward a little bit in the interest of time and say that these machines that we have, so we started it with MetroWestCoders. We started this guy and we gave him, an 8 gig drive. If we wanted to, we could add all kinds of new drives. We could add, so if we decided later on he needed more space, we could add more space for him. If we wanted to give him another public IP address, we could do that. We can do all manner of things with this this instance. But that's sort of down at the level of creating just an individual machine. So any question there before I jump on to the next area? Okay. And I can almost, I have to try to stop myself, but not successfully on spot instances. In that one of the cool things about setting up these machines is you're renting a machine by the hour. So you pay that 0.7 of a cent per hour, and if you use it for 30 minutes, you still pay the hour. But you're guaranteed that the machine won't go away. But what if you have a task where you could handle some interruptions? Spot instances are basically where you're bidding on the very edge of excess capacity in the Amazon cloud. So let's just take a quick look at a spot instance. Request a spot instance. So let's take this guy, and we're going to go to a bigger machine because these T-styles aren't spottable, but we're going to pick this. And all of a sudden you see the price, and you see maximum price, and you say, well, what price am I willing to bid? And basically in spot world, the price is of these various types of machines is always changing. And so you can say, I'm willing to pay, up to, 0.021 cents an hour. And as long as the price, as long as the price that you've bid is above the market price at that moment, then you keep the machine. The drawback is, of course, that the price could go above what you've bid, and then you're given a 2-minute warning, and then your machine goes away. Now, you can do a lot in 2 minutes, but not a whole lot. But so if you have a workload that can handle interruptions, you can pay spot prices which are typically, not always, but typically about 15 to 17% of the normal cost of an instance. So over time, you can save a tremendous amount of money. And so Morgan, going back to your idea of you want this to be your development machine, at least one place that I worked, I made my development machine where I ran my Eclipse and IntelliJ a spot machine. And you might say, well, Brian, that's just proof that you've truly lost it, because my development machine is the machine where I can't possibly sustain outages. But with if I've got my image built with all my cool stuff on it, I can, if I do lose the bid, I can spin up a new one, then use git pull, and within a minute or two be back up and running. So it's a strange new world.
That's awesome, and I don't want to have any more time. But Eclipse is not a command line application.
Right. And there are ways around. There are ways to get around that but I just don't have time to show that tonight. But you can absolutely do that. You can actually you can absolutely get run GUI programs on these machines. It's just more involved than I have time to show tonight.
That's cool.
Okay, so that's instances, and I took way longer than I really intended to. But let's suppose next that you want to create a database, and you don't care about virtual machines. You know, that's for people down in the weeds. You just want to create a database. So let's go create a database service. And I can't believe I don't have this up. So I'm actually going to pull this. Well, actually, I have to be in edit to do that. But RDS. So RDS is the relational data service, and so basically they're treating databases as a service, and you can have all kinds of different databases. So let's run one. And you see this very cool bar over here. It says, well, what kind of database do you want to run? If you run Oracle or SQL Server, then there are licensing things to deal with. But if you're going to deal with Postgres or Mariah, which is the sort of the redo of MySQL, or Aurora, there's no licensing. You just set it up. Now, Aurora is sort of the new kid on the block, but basically what Amazon did was do a clean sheet re-implementation of MySQL from a totally cloud native point of view, and they assert that you can have 5 times the throughput of MySQL for, well, they go back and forth between saying 1/5 and 1/10 of the cost. But let's just stay with MySQL for the moment, a community edition. So and here's a shock. I mean, I make Amazon sound so great. Here's a shock. They're recommending their tool. What a shock. But for now, let's just make a development test version of MySQL. And one of the reasons that this is development or test is it's only going to be running on a single machine. If you were running a real production database, if you're running a database for real, you would want to have multiple copies with clusters and backups and failovers and all that kind of stuff. But let's just play with one for now. And they warn you know about the limitations. Okay, so again, though, we get to say all of those cool instance types that we saw previously. You know, what do we want this database to be running on? And T2 medium is just fine. Here I'm going to have to do another tiny bit of explanation. So in Amazon there are regions and availability zones, and a region is a geographic area like U.S. East, U.S. West, Japan, Ireland, and so on. Within each region, there are multiple what they call availability zones. The availability zones are distinct physical buildings with separate power supplies and connectivity and all that. So, in general, basically the sort of the reverse Maslow's hierarchy of needs. When you're first starting, you make one instance in one availability zone. And then when you get a little bit more sophisticated, you put instances in multiple availability zones. So if a zone fails, and it's not common, but it does happen. 3 or 4 months ago, we had a really bad Sunday followed by a really bad Tuesday, where one of the zones in East was down. But then you put things in multiple zones, and then eventually you put things in multiple regions. And there are corresponding additional costs and transport delays. But for now, let's say, no, we're not going to do multiple deployment, and we're going to have general purpose SSDs and a little tiny storage. And this is gonna be, my DB, and it's gonna be root, and oh, it's not gonna. Okay, it wants a better password. 1 sec. Okay. Oh, there we go. Okay. So now I'm setting up, I'm setting up my SQL, and again I'm going to take pretty much all the defaults. We're going to create a MyDB database, default ports, default everything, just to show you that you can. But even here, you can have monitoring. You can do you can set up that they will automatically do minor version upgrades for you. You've got backups. I mean, you're getting a lot just for the start. And here we are. We're creating a database, and we've got a database going. Now, this will take a little bit of time to pop up. So I'm going to actually skip some of the things I was going to show you, but basically I was going to show you in MySQL Workbench, and this is a previous view, that I was able to connect to the previous incarnation of this database that I had created. We can go in basically from the Workbench, or we can jump on one of these machines that we've got created, and we can talk to the database. And this really is the database as a service, where you're not so concerned about the details. Maybe your company's forte, the goodness that you're bringing to the table isn't databases, but you need to use one. So let Amazon do it. Why not? And this does take just a little bit of time. You can see that it's progressing, but we'll come back to that. Okay. And there are a variety of services that Amazon provides, and I'm gonna come here. So this is database as a service. You have CloudWatch is monitoring as a service. CloudTrail is auditing as a service. Actually, let's go to CloudTrail. So CloudTrail gives you a log of every API call that's been made against your system. And so these are the actual API calls. You can see this is the timestamps of what we've been doing. So here we have create an image. Remember, we were making that AMI. We were creating some tags after we ran an instance. We were authorizing security groups. So you can very quickly see everything that's going on in your system, and this is all for free, and this is stored in their cloud file storage, and you can do a lot of queries against this that we don't have time to show. But one of the most interesting uses for CloudTrails are you can let's see. We'll click on one. So you can see that this came from a particular region and a particular source address. Now that happens to be my address, and I know that. But let's suppose that this said, Asia Pacific. Well, I'm not running in Asia Pacific. Right now, I don't know anyone in Asia Pacific. Pretty clearly, someone's hacked. So you can do all kinds of queries against CloudTrails to look for calls that have been made from any API or any sets of APIs that you care about, to see, is anyone messing with your system? Because Amazon, works really hard to make things protected, but it's still up to you to pay some attention yourself. So CloudTrails gives you the ability to do that. I am vamping a little bit while the database comes up. cloud search. If you want to do searches against your systems, let's see. We have directory services. We have Route 53, which is routing. When we get to Lambda in just a little bit, we're going to talk about the simple event system and the simple notification system and the simple queue system. So part of the thing when we were talking about at the beginning was that you can view the cloud from a lot of different perspectives. So you can spin up individual instances, like we said. You can spin up databases, and let's see how that guy's doing. Oh, he's still creating. I will say the RDS seems to take quite a while to create, but you're not doing that all that often. But all these other services they provide, there's a lot of things that you don't need to write. I mean, a lot of our systems require a database. A lot of them could require, a queuing system. A lot of them, a lot of our services, it would be nifty if they could send text messages. Well, you don't have to write any of that. You can use their services for that.
I can see the value of something like CloudTrails without even using too much imagination, because you could imagine having to write all that yourself if you weren't using their stuff.
Right. The other thing is it's not just security. You can also do it as sort of a poor man's analysis of your own system.
Right. Exactly. Right.
So I mean, because it shows literally every API call that's made. If you saw, if right around here things got slow and you saw that you were making a burst of calls, maybe a burst of the same call, well, you just found some loop that's maybe a problem. So, gives you a lot of ways to look at things. Yes, I'm not going to rate the console right now. So you can also, let's see, just given the time, I think I want to show you guys Lambda, because Lambda is just the most unimaginably cool thing there is.
Han Solo said I can imagine an awful lot. But I think in the case of lambdas, you're right.
Yeah. So let's take a running start at lambdas. Well, suppose we have some service that we want to provide in the cloud. We could spin up a machine and run some program on that machine. We could run a service, and hopefully that would handle the requests we're getting. But how about we don't spin up anything? How about we simply handle events? So a lambda is basically a little bit of code that gets executed when an event happens. So let's create a lambda. And I have some pre-made in case I screw this up, because I've been doing demos long enough. Basically, Amazon is providing, oh my God, the last time I looked this was 18 templates. Now it's 35. I don't see how any of the other cloud providers are ever going to catch up. We have blueprints for, let's do something if a file gets uploaded to S3, and S3 is the simple storage system. Let's get an event if someone changes one of our configuration rules. Let's see. DynamoDB. Let's is another one of their databases. Let's have an event if something happens in Dynamo. And I'm actually just curious what some of these guys are. Let's have a lambda that handles whenever we write a CloudWatch log. So you could have something that automatically processed the logs. or processed Splunk logs. Let's see. Alexa, if you don't know Amazon's Echo tool, Alexa is their Siri, and you can have lambdas that play with those things. But let's go back to this first one. So we're going to write an object that we're going to write a lambda that gets triggered when you have an event. And just before I do that, let me show you what S3. Let me just show you S3. So S3 is basically like a bucketized file store out in the cloud, and so I have 4 buckets. This is my CloudTrail buckets that shows me all the logs that we were looking at, and I can go in and eventually we'll see all those. Each one of those API calls ended up being a little JSON file, but I've created all these buckets and I can load files into them. So basically, I could say, for example, let's see, I clicked on this action, upload a file. You can see that I've had various files here. I can upload a file, and we're going to create a lambda that gets triggered when I upload one of those files. So let's go back to, let's pull lambda up here, and let's put S3 up here. Okay, I'll go over to lambda. Back again. So let's create a lambda function, and we're going to create one that gets triggered when I do S3. And so we're configuring what the source of the events are. So this is an S3 event from my CloudTrails bucket, although actually I'm going to change this. I've created a bucket called Lambda Event Source. Okay. Now what type of events? Because there are all kinds of events that might come out of there. And I'm going to say object created. And I could specify, no, I only want certain objects are created, but I'm not going to do that. And then I go to next, and check this out. It's written the Python code for me. I mean, this is kind of astonishing. So basically, if I save this, I've got a Python lambda that will get triggered when this event gets triggered. So let's say run MetroWestCoder 1 Python, and so you can see it imports some Python-y things. It gets access to the S3 system. You have a lambda handler. It gets handed the event, that the S3 event, and some context about that. It figures out the bucket. I mean, part of the thing is you need to understand the structure of the event in order to know what to do with it. But since it's your event that you're responding to, you ought to learn about it. But here's the thing that just strikes me as so cool. Well, maybe I don't really care for Python. I actually want to write in Node.js. It just wrote us the Node.js version. It's doing so much work for us. It's doing all the scaffolding for us. Now, you may notice here that Java 8 is an option, but if we pick Java 8, it doesn't have the inline capability yet, so you have to go outside in Java 8 and create a jar, and then you upload the jar. So why not stay with Python? And we'll go ahead and we'll call this, one. Now you come down here and you see this is, the handler is the lambda function, lambda handler, and then it's talking about role, and it says The role is for permissions. And bear in mind, this Lambda is going to want to interrogate S3 to get some details about the event. So they're even saying, hey, when you click this box, we suggest you pick the S3 execution role. And they've already got it starred. And it's like, okay, I'll do that one. Thanks. And why didn't it just take that for me? Oh, because I already have one. Sorry, I don't need to create a new one because I already have one here. Okay, from the last time I did it. You can say how much memory your system is going to use, and you can say the timeout. And this is really cool. So right now we're saying the maximum this thing should run is 3 seconds. So you have to understand the context of lambdas. Lambdas typically run in 10, 20, 120 milliseconds. And Amazon charges you in increments of 100 milliseconds of execution. And the first million executions a month are free. I know people say, oh, Amazon, they're big bad, but the first million executions a month are free. So it's hard not to love that, I think. And then we say next, and we say enable now, and we're good to go. And we've got it running. And it occurs to me that I'm not going to be able to, actually, I should be able to. There's no real way I can tell you that I got a text message. But let me turn the volume up on my notifications, and let's go back to my functions and I'll look at one of my another one, and these guys are still running. Okay, so let's go to S3, and hopefully you'll hear a ding, and you'll have to trust me that that ding was that I got a message. So let's go and let's upload something. Okay, that works. I'm going to start the upload, and it's done. And if the gods are smiling upon me, I'm going to get a ding in just a second. Unless it went, I just got a message. It said, Lambda topic, test published from test published from SNS to SNS from Lambda. Oh, maybe, can I show you that? Did I get that? Oh, okay. It's on my phone, not on my computer. You'll just have to trust me. And it said, test published to SNS from Lambda for bucket Lambda event source and 30 underbar Wi-Fi icon.jpg, which is the one we just did. So it would be cooler if my, it didn't beep because it went to my watch. Okay. But can someone say they believe me? You don't have to believe me. Let's look at the Lambda logs. So let's go and let's look at the logs. Monitoring. Okay, maybe it wasn't that one. One of these logs should have just sent me there we go. Invocation count. We had an invocation just then. And it ran for 918 milliseconds, which is pretty long for it, but it did have to go to send a text message. Let's view the logs. Dun, 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 dun. And hopefully it's the last one. Should be the most recent one. And look at this, start of Brian's SNS function for that JPEG. So with a ridiculously tiny bit of code, most of which we didn't even have to write. I got a notification on my phone that someone uploaded a file. Now, maybe deleted file is more interesting, or maybe that's a read-only area that no one should be uploading, but it's not hard to imagine more interesting things you could do. And let me show you
Could you even could you somehow download these logs so you can do your own kind of homegrown analysis on them if you want?
oh, of course, of course.
Yeah.
Yeah. And so this is the finished one where I say, create me an S3 variable, find out the bucket that was uploaded, get the simple notification service, which is how you do text messages in Amazon, and publish, and this is the message that I got that we saw just a minute ago. And I'll explain this guy in just a second, and then you have, error handling, and you're done. But essentially, this is the entirety, and this line. But this line and this line are all that was necessary to add text message sending to this Lambda. I didn't have to provision anything. This function I wrote a couple weeks ago, and it's just been hanging out there. So that's fairly amazing. And you can have Lambdas call other Lambdas. You can have Lambdas triggered by crons, and so they can do things on their own. I think Lambdas are the wave of the future. Now, getting back to this, you will see this notion of an ARN, and that I think stands for Amazon Resource Name. And so you get these long googly. It's a resource name. It's an AWS resource. Simple notification service. It's in the East region. This is the GUID essentially for it, and that's the name of the Lambda. So that's Lambdas. And just to show you something completely different, to show you just how bizarrely widespread Amazon is, we're going to go from sort of the sublime to the ridiculous. And Amazon has this thing called Mechanical Turk. And basically it's, suppose you had a task, and this task was easier done by humans than computers. You wanted humans to read a piece of paper and make a judgment, and you were wanting, a bunch of these pieces of paper processed. Well, how would you do that? You hire some friends, you go to a temp agency, or you can go to Mechanical Turk. So basically, when you sign up for Turk, you can sign up to use it or be one of the people providing the service. And so let's suppose I've signed up and I want to whittle away my spare time helping random people do random things. So here's a guy who 6 days ago said he needed a bunch of receipts classified, and he's willing to pay 2 cents for every receipt that you classify. It's like, okay, well, maybe I need to be bored, or maybe I'm in a country, because remember this is worldwide, maybe I'm in a country where 2 cents for piece part when I can do a whole bunch of them isn't that bad. So, and these are called hits, or human intelligence task. So let's view a hit. Oh, come on. This always works. Demo gods, be kind. Come on. Oh, there we go. Okay. So, this is, somebody spent 55, it's VAT, so that's probably, let's see, I'm not even sure what, we see a country, global city, Tiago City. All right, Well, someone spent 55 currency units at whatever this convenience store is. You know, find out the phone number and the address and click next, and you've made yourself your 2 cents. And it's a strange sort of market they're going after here. And I mean, at some level, it strikes me a little bit of exploitive, because what are you doing that you're only paying people 2 cents for one of these things? You have to do a lot of them. Feels kind of shoppy. But on the other hand, it's work that might not be available. It's an option. I mean, just write a short description of an Airbnb property. Here they'll pay 10 cents. I mean, that's oh.
I assume it draws its name from the fake chess player, right?
Yes. Why don't you explain that? Because not everyone knows that in work.
I don't know when this took place, but long before there were computers, there was a pretend machine that was used to fool people into thinking that a machine could play chess, and the machine was actually large enough for a person to fit inside it and play chess, pretending to be a computer. I don't know if we should call this the reverse Turing test. And I guess stylistically, the machine resembled a Turk. Is that where it comes from? And so it was called the Mechanical Turk.
Right.
Yeah, I guess it fooled some people.
Right. Well, and it's a sort of task that this, it's got to be a segue into machine learning, which is probably the last thing we'll cover tonight. But look at this one. View a web page, tell whether it's handy, or whether it's helpful. Like, oh my gosh, is this the web page? Okay, how to go deer hunting. Let's open that. How to go deer hunting. You need a human to look at this and decide whether this is helpful. I don't know. Looks pretty helpful to me. It looks 10 cents worth of my time helpful. So let's 20 cents. Wow. Okay. I can get 20 cents for that. So that's kind of cool. So now the segue to machine learning. Machine learning is another one of these crazy hot topics where, and we'll walk through it in just a sec, but I want to give some background. You present a bunch of data and some sample answers, and you run the system against the data and essentially the classification of that data, and the system will come up with an algorithm that will make similar choices for other data. So one of the talks at the recent Amazon conference was, imagine you wanted to monitor your company's social media stream. And in that stream, there were people saying, good things and bad things and comments and attaboys and so on. But there's some data there that you really want to grab. So some people might be really reporting problems. And it would, even if they just tweet about a problem, you might want to have someone respond to it. And if they were having, if they had a good experience, maybe you wanted to send them a thank you note. But how do you if you're a big company, how do you handle the deluge of tweets and Facebook posts and so on that you might get? So what this company did was they took a random 1,000 or so tweets that had shown up on their social media site, and they created Mechanical Turk tasks for them. They said, classify this as I can ignore it, this is a customer having a problem, this is a bug report. And they basically, put that task out. The mechanical, 1,000 people or one person who was very bored classified the 1,000 tweets, and then they had a mathematical model that they ran against their incoming tweets from then on to classify the tweets and route them to be escalated as appropriate. So that's kind of a pretty cool combination of Mechanical Turk, which is sort of the lowest level thing that you can imagine them providing, and then machine learning, which is kind of the most sophisticated thing you can imagine. And we can walk through an example of that. I will say I am no machine learning expert by any means, though I would like to add that to my skill set. So we go to machine learning, and let's see, maybe I've already done one. Let's create a new one. Actually, let me just stop for a second because I was doing this earlier. Create a machine learning. Let's create a machine learning model. Let's create a data source because, as they say, garbage in, garbage out. Machine learning performs statistical analysis on your training data sources, and so on. So let's just create one. Okay. Let's see. Did I had one set up? Hold on a second. No. I may be diving off into the weeds here, but actually, give me just one more sec. Create a new source model. There was a test data source that I could create. I'm sorry. I'm just gonna take us off into the weeds, and it's 9:45, so I'm gonna not lead us down that path. So I think I'm gonna wrap it up, but as you can see, we've scratched the surface of the things that Amazon can provide you. Each one of these can be and is I've seen offered as day-long seminars, but you get the sense of basically the scale from individual machines with a few hundred megs of memory down to all the way up to giant systems, all the way over to systems where you don't need a machine at all and you just write little bits of code. And we can go over. I could go over all of these, but hopefully this has given you a taste of things. And let me go back, and I'm going to stop the screen share.
You know what strikes me, Brian, about all those things that you say could be a day-long seminar is that those are all packages, whether they're an analytics tool or an auditing tool or a file store or whatever. Those are all things that I'd have to invent and integrate myself if I didn't have AWS. It seems like I can just get right to the biz logic and not solve the infrastructure problem.
Right, exactly. I had a buddy once who was he basically invented PowerShell, and back in the day was a direct report to Bill Gates, so he knew a thing or two, and he said the first 2 million lines of code are table stakes, and what you bring to the table afterwards is your value add. Well, don't write the first 2 million lines. Let someone else write them. I was at a company where we were arguing about how to do security, and I said, well, we have a security guy at our company, and he's really, really smart. Amazon has 200 security experts for their web service security system. our guy is smart, but he's not smarter than all 200 of them doing that, and that's the only thing they do. So, focus on what you bring to the table. So, I mean, I mean, yes, any of us could probably write the text messaging system, including timeouts and retries and confirmation, but who wants to do that?
Right.
So, anyway, any questions? And I'm impressed that people stuck around this long.
Yes, actually, to bring you back around to things which can go reasonably on a slide, what are the resources you recommend for learning more about AWS?
Okay, great. They have some, actually right on their web pages, they have some outstanding tutorials on each one of those services. There are great tutorials and great white papers. And when I learn when I'm learning a new system, and so like when I go back and learn machine learning, and I thought I could wing it, and clearly not. But what I would do is I put up two windows. I put up the machine learning console and then the tutorial page. And the tutorial page is wonderful, just walking through. So their white pages are really quite good. Boston has an Amazon Web Services meetup. They actually are meeting tomorrow. They're having a series of talks on deploying Elastic, Logstash, and Kibana that I would really like to go to, but I don't think I have a hall pass for tomorrow. So there are, I think there's a couple of books on, Amazon Web Services for Dummies. And the For Dummies books are wonderful, by the way. But part of the thing is that Amazon is innovating at such a fast pace that is very hard for a printed book to catch up. I do this thing for a living, and you saw me find 2 pages on this thing that I never seen before. I need to go back and find out what the heck they are. I worked there this afternoon when I was at work. So yeah, their stuff tends to be up to date, and that's really the best way. And then and while we're talking, I'm just gonna go back and delete my running instances so that I don't keep getting charged for them. I'm just gonna and my point was that some of this stuff is so inexpensive. They have a free tier. When you create an account, you have a free tier where you can play with almost all the services for free for quite a while. Some of them indefinitely. Lambdas. I don't think I've incurred a penny of cost in Lambdas because I sure haven't hit my 1 million hits a month. So you can just play with it. And
I took a MOOC a couple of years ago. I took a MOOC a couple of years ago, and the platform for the MOOC was AWS, and they said just sign up, and everything for that year was free. It was quite an interesting education model.
Right. Well, it's worth pointing out that Coursera runs entirely on AWS.
I didn't know that.
Yeah.
I'm a big fan of that, and I didn't know that.
Yeah, I've been taking some R classes on Coursera. So there's a lot of resources. Stack Overflow, of course, has last time I looked had something like 18,000 answered questions. On Amazon. So.
Okay, well, let me take this opportunity to thank Brian. Very well done and interesting. I also want to thank Robert and Stephen and Chris and Mitchell for joining. And I'll sign off.
All right. Thank you so much, Morgan, for organizing this and doing all the legwork.
Thank you.
Thank you.